Welcome students, let's begin with the topic of Universal Law of Gravitation. This is also called Newton's Law of Gravitation and it helps us to find out the magnitude of the gravitational force which is acting on the bodies. So what does the Universal Law of Gravitation says? It says that every object, mind the word every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the centers of the two objects. So, this universal gravitational law or Newton's law of gravitation, it gives you the force which is acting between the two bodies. And what does it says? That every body in the universe. This is a very big statement. That means anything which is around us, anything which is beyond this planet, right, beyond our solar system, all those bodies, even celestial bodies, stars, planets, asteroids, comets, everything, also everything on the earth, tree, human body, these benches that you see in your classrooms, the table on which you are sitting, everything, every body applies the force on the other body. And what is the magnitude of that force? It says that force F is directly proportional to their masses m1, m2 and inversely proportional to the square of the distance between them. Either you can take R or you can take D. Right? Now, in order to understand this law in great detail, have a look at the animated video.
Newton's law of gravitation. Definition: every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Mathematical expression for Newton's law of gravitation. Consider two bodies A and B of masses m and m respectively, such that d is the distance between their centers. Let F be the force by which these bodies mutually attract each other. Then, according to Newton, F is proportional to m into m. Statement 1. F is proportional to 1 by d square. Statement 2. Combining statement 1 and statement 2, we have F is proportional to m into m divided by d square, or F is equal to g into m divided by d square, when g is the constant of proportionality, commonly called the universal gravitational constant. It has been found that the value of gravitational constant does not depend upon the masses of the bodies, the distance between the bodies, the medium between the bodies. The formula for gravitational force is applicable anywhere in the universe.
So, from the animated video, you have learnt that the gravitational force is equals to G m capital M into small m divided by d square is the force on the gravitational force which m is applying on small m or vice versa. And what is this capital G? This capital G is also very important. This is called gravitational constant. Okay, we will discuss in detail about the gravitational constant, but please keep in mind this formula. This is very important. Okay. Also, let us discuss the SI units also with this. Force, what is the SI units of force? It is Newton. What is the SI units of mass? It is kg. This mass is also kg. SI units of distance, it is meter and square, since it is square. Keep these SI units in mind and this formula in mind. We will be using this to find the gravitational constant. Okay. Now see, as we have discussed, capital G is the constant of proportionality and is called the universal gravitational constant. Now how do you find this universal gravitational constant? From the formula of force only. Force is G m over d square. So from here you can conclude F d square is equals to G capital M into small m. Take this into the denominator. Therefore, F d square so this is the formula for universal gravitational constant. Okay. Now try to guess the SI unit of G from here. See, G is F d square upon capital M into small m. SI units of force, it is Newton. SI units of distance square, meter square. In the denominator we have mass into mass, that means kg square. So this becomes the SI unit of universal gravitational constant. So the SI units are Newton meter square kg minus 2, kg to the power minus 2. And if you want to find the value of G, how do you determine the value of G? Value of G is 6.673 into 10 to the power minus 11 Newton meter square kg minus 2. This is the value of gravitational constant. You need to know this value also. SI units are also important. Okay. Now see, this point is also important to understand. The value of G does not depend upon the medium between the two bodies. That means whether you are in vacuum, whether you are on Earth, whether you are on Mars, or for that matter any planet anywhere in the universe, the value of G will remain constant, it will remain this only. Okay. Also the value of G is same throughout the universe, very important. That is why it is called universal gravitational constant. Wherever you go on the universe, see, universe is a very big term. Universe includes the bodies which are beyond our solar system, right? We have so many different type of celestial bodies which are far away from even our solar system. Our solar system encompasses 8 planets, and even beyond that we have celestial bodies. So this value will remain same even there as well. Okay. So it remains same throughout the universe. Next, note, due to the relatively low mass of two individuals sitting next to each other, the gravitational force between them is incredibly weak. We have discussed in the previous topic that suppose I have this pen and I have this remote control. This remote control is applying a force on this pen is applying a force on this remote control, but they are not moving towards each other, right? Why? Because the force between them is very small. The force between them is of the power 10 to the power minus 11 newtons approximately. This means the force is what? 0.00. Imagine this is the magnitude of force. Can you take it approximately equal to 0? For all the practical purposes, you can take it to be 0 only. That is why you do not see the effect of gravitational force between them, because their mass is very small. Imagine the two benches that are lying there in your classroom, or the bench or the table and the bed in your room. They also have gravitational attraction force towards each other, but they are not moving towards each other because again the mass is very less. See, if you try to calculate, let me give you a estimation so that you understand it. Let's say the mass of your bed is 1 kg and the mass of your table is also 1 kg. For simplification of the calculation, let us assume this. Okay. So, m is 1 kg, small m is 1 kg. Let the distance between the two be 1 meter only. Right. Now, force will be what? 6.673 into 10 to the power minus 11, mm is 1 into 1 divided by 1 square. So, what is F coming out to be? 6.67 into 10 to the power minus 11 Newton. Can you see the magnitude of force? This is so small. Look. This is the magnitude of force. Can we take it to be 0? So, the force between your study table and the bed is approximately coming out to be 0, but although it is not 0. Okay. That is why you do not see the effect of gravitational force on the objects that are lying in front of you. Next, the universal law. The law is universal in the sense that it is applicable to all the bodies that we have discussed, whether the bodies are big or small, whether they are celestial or terrestrial. See, celestial body means those bodies which are beyond our planet Earth, right? For example, Mars, Jupiter, Sun, all these planets, satellites, right? Moon is a satellite of Earth. That is also a celestial body. Asteroids, meteoroids that you see, all these are your celestial bodies. So, even on those bodies this law is applicable. Terrestrial means all those bodies which are on the surface of the earth. That means the table, the bed, you and your friend, your family members, the board, the pen, all these objects, on these terrestrial objects also this law is applicable. That is why it is called universal law. Okay. Then you need to understand the meaning of term inverse square. We have already discussed that this force is inversely proportional to the square of distance between the two objects, right? Now look at the statement over here. Saying that F is inversely proportional to the square of the distance d means, for example, that if d gets bigger by a factor of 6, suppose initially m and small m, they are d distance apart, but we make d to be 6d. Suppose this m, this becomes 6d. Under this situation, how the force will change? See, instead of d, write 6d. This will be the formula, 6d whole square. Now open the square. This means F is inversely proportional to 36d square, right? That is what it is saying. The F becomes 1 by 36 times smaller. Initially F was this, let us say this is your new F. So, this has become 1 by 36 times of this F, right. This is the meaning of inverse square.